Hello, I'm Lee Bernick, Dean of the Greenspun College of Urban Affairs, and I want to welcome you to another edition of the Urban Report. Today's edition is going to focus in on award-winning students in the College of Engineering, and my first set of guests are the winners. Is that right? Did you win the grand prize?
Yes.
Is that
Yes.
the grand prize? And so I have here Annie Bouck and Brian Vincent. Is that right?
Yep.
And you're both from, and this is great, you're both from Vegas, right? You're from
Yeah.
Las Vegas, and you're both engineering students?
Yep.
Right, civil engineering.
Civil engineering, and you are graduating
Yes.
Sunday,
Yes.
Yeah.
right? Let me just out of curiosity, how long did it take to graduate here?
For me, it actually took 5 years, but that's also because I did 2 schools full time. The other school was actually a school of ministry for the first 2 years.
Okay,
I'm kind of unusual. I finished in 4 years.
4 years.
Yeah.
Okay, especially in engineering,
Yeah.
that's great.
Yeah.
And so it's terrific to have our own homegrown Las Vegas engineering students who are winners, right? And so there was a contest, design contest, is that right?
Yeah.
Within the College of Engineering.
Right.
And did you, and this was done just a couple days ago, is that right?
Yes.
Okay, and what were the parameters of this contest? Can you-
Basically, it's a little bit different for the different disciplines. If you talk to a mechanical engineer, they'd probably tell you it's to invent something, like an actual prototype, but it's not that way for civil engineers. We kind of design a process, or like what we did with designing a water supply system, which it's not a physical thing that we have, but we have the calculations, all the analysis, everything that we've done.
Okay, so you don't have, when you get ready to do the contest, and when you're in there, it's more like the old traditional science, probably, in terms of designing things. They're not,
It's like a
there's
really-
no working, there's nothing, and
Yeah.
right? You
Yeah,
can't
it's kind of
bring-
like a science fair on steroids.
on steroids. Well, that's a good point about this. So you mentioned a little bit, what is it that you designed?
We actually designed a water supply system that would bring aid or bring water to the villagers and an orphanage that's located in Moshi, Tanzania. So basically, currently they travel about 3 miles to obtain their water round trip, and so we're building an entire system that will help supply them with that water.
And how did you come up? I mean, did somebody say to you, we need to design it? I mean, were you given this project, or how did this all come about?
There's a little bit of a background story, and I think it's a little bit different for each of our team members as well. I did happen to, my aunt introduced me to a Christian missionary who works in Tanzania. His name's Bouck, and he told us about the entire project. But as far as like why pursue a project like this, for me personally, it's always been a desire of mine to do something like that ever since I had this, what I would say is a pretty crazy experience in basically encountering who I call Jesus Christ. And just when I encountered him, his love was so overwhelming to me that I wanted to be able to share that love with others. And so when I entered into my college career, I desired to do projects like this where we would be able to bring water to people who are in need, like people dying simply because they don't have access to water is kind of ridiculous.
Okay.
So I wanted a way to be able to share that love. But for each of our team members, it's actually a different thing.
Okay. And you say team members. How many members were there on your team?
There were 4 of us.
There's 4 of you. And how many teams were there in the competition?
36.
36 teams. Okay, and you mentioned the fact that there are some that are mechanical and
Yeah,
some
all the
that
different disciplines. So
in all different
mechanical-
disciplines. And do you win within your discipline and then win the overall, or is
So there's different awards. You can place first and second prize within your discipline, or you can get grand prize. So they don't have a team that gets both first prize and grand prize. And then in addition to other awards, there's a sustainability award that we also won.
so you won a sustainability award as well as the grand
Right.
prize?
Yep.
That you can double up on.
Right. Right.
Okay, so and it's sustainability because you were helping out, or is it that the actual project itself is sustainable, or is it that you are creating something that helps make a sustainable society, or is it both?
I think it's mostly centered on our project was considered sustainable. We designed a system that didn't use energy, didn't use a lot of electricity, or didn't use any electricity actually, so it didn't require a lot of costs, and it was something that could be left around for a long amount of time, so people after them could continue to
So,
use it.
do you envision this actually being implemented?
Yes, definitely.
So you can probably talk more about that.
Yeah.
Yeah.
So so you designed this now. You mentioned that it doesn't use electricity. Now, how do you get it? So essentially, it's going to be a mile and a half away because you
Yeah,
said there
about.
was a 3 mile, but it's some mile plus distance, right?
Yep.
And is it all by gravity?
Yeah. So
Yep.
basically, it's the villagers get their water from a spring source, and it's about at the base of Mount Kilimanjaro. So it's a very steep elevation change. So when we designed the pipeline to carry that water, it's completely gravity fed. We don't need any pump. Anything to bring the water down. It comes down on its own. We actually had to design ways to reduce the pressure because it was so great, because the elevation change was so great.
So it was coming down too hard,
Right, yeah.
too fast.
Right, essentially, yeah.
Okay. So you want to talk about this in a second about how it's going to sustain, but why wasn't this done before? I mean, if nothing against you, you know, or anything, you designed this. But how did gravity not come into the? How did we not figure it in? Do you have any idea about this?
I mean, like using gravity in water systems overall?
No,
or?
I mean, why didn't they have this done?
To the specific place.
To the
I think there's a lot of places all over the world that don't have access to water, immediate direct access to water, and I think that I don't think this is that unusual of a case. I mean, we're so numb to it because we can just turn on a tap and get our water, but in reality, it's not really like this everywhere else.
Okay.
Yep.
So.
And so I just have 20 seconds or so here. Tell me, you think it's going to be sustainable in the sense that it'll stay on once you actually
Yes,
implement?
absolutely. I mean, we've had to even place pressure reducers. They could actually obtain electricity by inputting turbines on the entire system. So because the elevation is so high from where the orphanage and village is compared to where the spring is, or the spring is higher, we'd be able to get electricity from that pipe if we were to put turbines on it.
Okay. Well, it's fascinating, and it's great to have you on. I'm going to have to end. We'll have to have you come back and tell us a little bit more, or once somebody come back. You're all graduating. Hopefully you won't forget about UNLV. So let's stop here. We're going to take a break, and we'll have a couple more award-winning students from the College of Engineering. Thank you for coming over to the Greenspan College.
For others, it may have just been a summer job. But for me, it was training. Now I'm an Air Force pararescueman, and my job is to save lives. Make the right choices today, and be ready for the challenges tomorrow. This message is brought to you by the U.S. Air Force.
Think you found every hazard out here today? Think again. The spot you missed could be a killer. That spot on your skin could be skin cancer. Fact is, if you're a man over 50, you're in a group most likely to develop skin cancer, including melanoma, the kind that kills one person every hour. 1 in 5 Americans is likely to develop a form of skin cancer during their lifetime. That's why your best shot is to check for a spot. It's easy. Follow through and check your skin. It could be the save of a lifetime. Go to spotskincancer.org to find out how. A message from the American Academy of Dermatology.
Winston, just one more inning, Grandma.
Ever notice how many things today kids can do without actually moving? A whole lot of things their parents used to do the hard way. So many kids' activities today seem to leave out the activity part, which makes exercise even more important for children. In fact, new research tells us the best time to enhance bone development is during childhood and adolescence. And just getting children to walk an extra 35 minutes a day could spare them the pain of thinning bones later in life. Healthy bones come from healthy habits. Encourage your kids to get up, get out, and get moving.
Hello.
Hey, Grandma, how about another grape soda?
A public service message on building strong bones for kids from the Pediatric Orthopedic Society of North America and the American Academy of Orthopedic Surgeons.
Welcome back to the Urban Report. In this segment, we have 2 more award-winning students in the College of Engineering. and I have to tell you, this may be way beyond my my understanding of things. So I have here Marc Gurney, who's a computer engineering student,
Correct.
and Mike Mish, right?
Yes, sir.
And you're in electrical. Are you in electrical engineering?
Yes, sir.
Right. And what year are you?
I'm actually graduating right now.
And you're
so-
going to graduate Sunday also.
Yes, sir.
And what year are you?
I'll be graduating in December.
In December. So we still have you around for another semester.
A little bit if you got more questions.
And and what year? I mean, where are you from?
Actually, California originally.
Okay. And Mike?
I was born in Idaho Falls, but basically grown up here.
Okay. All right. So you won first place in the electrical engineering.
Yes.
And what did you do to win the electrical engineering competition?
Well, we finished our project, so and let me tell you, that was a doozy.
That was a doozy. Okay. How many? Well, let me ask you this: how many people were on your team? Just the two
just
of you?
us.
Just the two of you.
Yeah. Yes.
Okay, because the other group had 4 people. Maybe that's why they came in first place in the overall. They had 4, and you had 2. That's not fair. Okay.
Yeah,
Yeah.
I agree.
Okay.
I'm going to concede that point.
Okay. So anyhow, the two of you designed a keyboard, right?
Mm-hmm.
That's not a keyboard.
A ghost hand keyboard.
A ghost hand keyboard.
Mm-hmm.
Okay. So there's no keyboard. We're just assuming that there's a keyboard.
Right. So we're very excited about like Google Glasses and augmented reality glasses, basically glasses that show a display over what you're seeing. So we decided to create an input device that would work, that would still kind of like make it disappear without you carrying around a keyboard to make it work.
Okay. So we're going to go to one of the slides here, and I think the first slide is one of Mike. Can you tell me about this? What what the audience is seeing?
The person that's wearing it is Morris. He's a fellow engineering student. The thing you can see on his wrist is what we've actually designed. Everything else is kind of a pseudo built-in way of us getting bypassed the fact that we couldn't purchase the Google Glass. And you can see the camera in the lower part of it. The computer itself is on the upper part, and on the bottom is a battery. And it's just a camera that can actually see where your hand is and translate that into IR images.
Now, wait a minute. Sees where your hand is over it, right?
Yes.
And then you say IR images. What are IR images?
Infrared light.
Infrared light. Okay. So if we can go to the next slide, it gives you a more detailed picture, right, of your...
Right. Now, this is actually the wrist unit itself. And if you look at the lower left-hand side, you'll see a fisheye lens.
Right.
Underneath that is a camera that actually reads infrared light, and around it are sensors that actually emit the light. So you'll see on the left-hand side with all the pictures, I think it's the left-hand side, the image that is actually read by the camera. And you'll see at the very top, all the fingers are actually a certain distance, and when they get closer, you'll see that a larger light actually indicates that it's closer.
That's in the bottom picture.
Right.
The top picture shows you the fingers in general, and then the one that moves, if I'm moving that finger, it gets closer, it gets to be this larger light.
Correct.
On that. But there's a computer.
There's actually a computer we use the Raspberry Pi, which is a little $35 computer coming out of the United Kingdom right now. So it's kind of an educational tool, but it was inexpensive. It wasn't extremely powerful, but we thought it was a great little tool to utilize and make our project happen.
Okay, we've got to get to the next slide.
Okay, of course.
But no, I have a whole bunch of questions about this.
Oh,
but go ahead.
hopefully we
So
answer
this
it.
next slide shows us what?
This was an example of what we were using, and as you can see, the orange light is exclusively the infrared filter. So everything else is just extra. So we focus in on that, and you'll see that there's a circle around the fingertip.
Okay.
And we translate that in particular to the coordinates at the very right-hand side. We have an X and Y coordinate, and that gets sent to whatever Google Glasses you're wearing or whatever augmented reality you're using, maybe a heads-up display in your car or something like that. So, and it's a very simple thing.
Well, wait a minute. I'm just going to
Well,
interrupt you here
of
for a
course.
second. There's a couple things. One is we really shouldn't be doing this stuff in the car. You should be paying attention. So I'm
agreed.
just going to say right now, let's stop with the car stuff here.
Well,
okay.
our idea is to make sure it doesn't work if you're moving.
Okay.
So
That will
we've
be
already
okay.
considered
All right,
that.
we'll consider that. But so Well, let's go to the next slide, and then I've got so many questions to ask you. Okay, so now what is this one?
In the final slide, it's similar to what you'll actually see if you're wearing the glasses. The unit will pick up your finger, it'll tell you where you are by that little white hand cursor, and it'll go over the keyboard in the lower right hand. So it's what you're actually going to see if you're using our unit.
Okay, so this is important to me because, again, I'm still not used to this notion of virtual. So I would be wearing the glasses. On the glasses, the Google glasses, would be the image of the keyboard.
Correct.
Right? And then as I move my hand, I'd be able to say, well, that's where the E is, or that's where the B is, and if I move my hand down, I'd be pressing on the B.
Right.
Right?
That's exactly it.
And so I don't need any keyboard.
Correct. It's all on your wrist.
It's all on my...
It's all on your wrist. Well,
no, it's all
over
on my
your
glass.
wrist. Yeah,
it's right.
It's
on
over
my
your
glasses.
wrist. So.
But I'd have to figure out. I'll have to learn how to coordinate my hand with my eyes here in terms of.
It works like a mouse. Like if you look at a modern keyboard, the mouse is just a pointer. You never actually look at your hand.
Yeah.
You just know that moving your hand to the left moves the pointer to the left.
Yeah.
And so that's basically the idea. Is you can always see where your hands are. So it should be very intuitive.
Okay.
So you should be able to pick it up like that.
All right. So you've done this now. Do you have any ideas about patenting this thing? Is this a patentable?
Yeah, we've contacted the UNLV's department for that. Unfortunately, we couldn't make a meeting. They want you to meet with their patent lawyer. He's only here for the first 2 weeks of a month, and
so they're in
just
progress.
didn't have time.
We've been busy trying to make this happen.
Okay,
Yeah.
so you made it happen, and we have to wrap this up.
Oh, of
this
course,
is just
sure.
totally fascinating
Well, thank
to
you.
me. I'm glad that you came here, and hopefully, even though you're graduating, you're going to be around, and both of you can work on still getting this thing patented. Maybe this is fascinating, and again shows the kind of creativity and expertise that we have in our students at UNLV.
Thank you.
Thank you for coming to the Urban Report. We
Thanks for inviting
appreciate it.
us.
Thank you.
Thank you.
If you could see anything in the world, what would it be?
I'd love to see Paris.
I like to see cupcakes falling from the sky.
My daughter, married and happy.
I want to see things the way I used to.
Chances are, someone you love may one day be affected by macular degeneration or glaucoma. Log on to seeabettertomorrow.org or call 1-800-437-2423 to learn about glaucoma and macular degeneration. Call 1-800-437-2423 or log on to seeabettertomorrow.org.
I just want to see more of the things I love.
I remember the moment.
I'll never forget that moment.
That moment?
It was a moment that changed my life. I'd been training with my team for months, and now we had been called up for the first time. The real deal. Wildfires were getting dangerously close to homes. At that moment, I got my first taste of just how important the Guard is to my community.
See how the Guard can be an important part of your life at NationalGuard.com.
At what age is the color that your skin was meant to be no longer beautiful? Every year, millions of young women try to change the skin they were born with and say they die for darker skin. Sadly, some actually do. Melanoma is the second most common cancer in teens and young adults, and one person dies from melanoma every hour. Change your thinking, not your skin. Stop tanning. Learn more at spotskincancer.org. A message from the American Academy of Dermatology.
Something's not right.
My first symptoms were
constant tingling in my toes.
My legs, sometimes they'll go numb.
Double vision. They said you have multiple sclerosis.
Well, the beginning is the hardest time.
Kind of had to get a grasp on reality.
I had to adapt and change very rapidly.
I had to learn how to drive with my hands. Yeah, that was interesting.
I was a dancer. I don't see walking the way I walk any different than doing a dance. It just looks different. It's a different dance.
You see me have an off day, it doesn't take away from who I am.
A symptom may cause you not to be able to do that anymore. And at one point, I wasn't able to do any of those.
But I would exercise every day.
Since I've been cycling, it's definitely helped my walking.
To make a lot of changes in my life and just adapt to it.
I'm going to acknowledge its presence. I'm not going to discount it, but at the same time, I'm going to try my best to not let it stop me.
It's a fantastic opportunity to be working together with a common goal of curing MS, and sharing is the key.
Welcome back to the Urban Report, and in this segment I have 3 students who are again award-winning engineers in our College of Engineering. Let me go around and see if I have this right. Khoa,
yes.
Right? And you're from Vegas, well, originally from Vietnam, right?
Yes, sir.
But graduated from Vegas High School. Okay, and Ron, is that right? And you're from San Diego?
Yes, but I went to high school here, went to Advanced Technologies Academy.
Okay, so you went to high school here, okay? And Neely, right?
Yes.
And you went to a Vegas high school too?
Yes.
And I mention that because I think it's important for people to know that we have really bright students coming out of our high schools. Everybody always hears about the local schools and everything. It's nice to be able to say that we have award-winning students coming out of our high schools, and they're here. And so you entered this competition that was last week, and you're in the multidisciplinary category.
Yes, sir.
And it's multidisciplinary because you guys are mechanical engineers, and she's an electrical engineer. She's a double E, right? Isn't that right? A double E.
That's right.
Okay. They want to be engineers. You're an engineer. Is that right? This thing. So we have mechanical engineers and we have electrical engineers, and you guys won first place. You actually have a 4th person on the team, right?
Yes.
And he was a mechanical engineer?
Yes, he was.
Okay, so 3 MEs and an electrical.
Yes.
Okay, so tell me, you designed a thing called?
The Reactor.
The Reactor, and in a second we'll get to it. How did you, before we start talking about it, but whose idea was this?
So we actually, at the beginning, we didn't have any concrete ideas as to what to follow. It was actually me and our 4th member, Brian. We were just sitting in the computer lab, and he actually has a 4-year-old daughter. So he's had quite a bit of experience with all those strollers and stuff, and he just said, you know, let's do something for babies. You know, let's do something along the lines of like products for babies. And he said, I hate my stroller. They could always be better. Why not make a better stroller? And that's exactly how it started.
All right, so we're going to see this video. To the audience, we're going to play this video, and then you're going to explain this. And this is a better stroller, right?
We can say it's an advanced stroller.
Okay, the video's up. So tell us about this. Who's going to tell us about it?
We can always just jump in
okay.
if we want. So.
All right, so tell us. Neely, okay, go ahead, Neely.
Well, as you can see, we have the folding system. All you have to do is press the power switch, which is located on the handlebar, and you can fold and unfold the stroller automatically.
It automatically folds and unfolds?
Yes.
Okay. All right. But we have to have some safety in there, right?
Right.
Definitely.
So therefore, we have this hand capacitive sensor our electrical engineer programmed. It's made of a copper material, and when you let go of the handle, another linear actuator pushes brake pads into the rear wheelbase, and within a second, the apparatus stops. So your infant isn't going to go drifting into danger.
Okay, so now it won't roll down the hill.
No, actually, at a 45-degree angle, it's basically works perfectly.
And that's what you're showing up here, that it can go over all kinds of terrain. And what you do, you don't have seats, you put in the regular, typical baby car seat or whatever.
Yes.
Is that
Well,
right?
we initially designed it to fit a Graco car seat. It's the best-selling car seat out there, and we didn't want to spread ourselves too thin, so we just went for one model right now. But for future versions, we want to make it so that we can take off the handlebar and actually put in a toddler seat so that you can use it for children up to like 4 or 5 years old, so that you have a longer service life for the product.
Oh, okay, longer service life for the project. And I have a couple questions here. First, how heavy is this?
It's about 31.5 pounds.
31.5 pounds. And you think that we can really just pick this up and put it into the car? I mean, have you tried this?
Yes, we actually have. We actually did it quite a few times on the way to and from the Cox Pavilion for the competition. And it's funny because that's actually one of the very first questions that the people asked at the competition. And believe it or not, the average stroller is about 35 pounds.
The average stroller is 35 pounds?
Yeah, you don't really notice it, but it's actually pretty heavy. So ours is actually a little bit lighter than the average stroller out there that you can just go buy.
Did you try to pick it up?
Yes, I did, and it was quite a bit heavy, but we can always fix it.
Okay. So now, you've got this system. It can't roll down the hill by itself, right? It folds down. You can put any kind of seat in there that, well, right now you're just looking at one Graco's, right? On seat on this thing. And who designed, I mean, how'd you design this thing? I mean, who's the designer of this thing?
So in terms of mechanical parts, we actually all had a say in it, but we started with some pretty complicated software that helped us visualize the geometry of the folding and unfolding system, and we had to go through quite a few different versions of it in order for it to get it to fold down completely.
Okay, so you had to design it, and you had computer software to help you design this, right? And then did you actually have to construct this?
Yes.
Okay, and who constructed it?
We all did.
You all did. Okay,
Mm-hmm.
so mechanical engineers should also be able to actually physically design, I mean, construct this, right? And did you figure out what materials you wanted on this thing?
Well, our prototype is actually constructed right now out of aluminum. It's fairly sturdy, it's fairly strong, and it's pretty light. But for future versions, we want to go with some sort of composite. And if, something along the lines of carbon fiber, but not carbon fiber because that's way too expensive. But if we do go with the lighter composite, we can actually reduce the weight to hopefully about 50%.
All right, I just a shorter period of time here, I wanted two things. Do you know how much this would cost if you actually were able to produce this?
Around $300 to $400 is our target range.
$300 to $400, the
Yes.
target range.
Right.
Okay, so it's not meant for graduate assistants who have children, is that right? I mean,
Right. But we believe an extra $100 or $150 is a small price to pay for the extra security for the infant.
Okay, so that's it, our safety thing. And are you going to, have you tried to get ready to push this out in the market? Is somebody talking? Are you talking to people?
Yes, actually within the next week we're trying to push a provisional patent to try to get this going, and we have a lot of investors interested in this project.
Okay, well, it'll be interesting to see soon. Hopefully we'll see this on the market very soon. We have to end this show in this segment, and I want to thank you for coming. It'll be interesting to see what happens with this. And I want to thank you all for watching the Urban Report. This segment, again, award-winning engineering students. The whole show was about terrific engineering students here at UNLV, and we are very proud of them. Thank you for watching the Urban Report.